Okay, so we have a chart right here. Well, I wrote PEMDAS at the top because that is something that you should have memorized. It's the order of operations. We always follow PEMDAS when we do simplifying. And today all we're doing is simplifying. So PEMDAS starts with parentheses, but we're not going to really be doing that today. We're really going to focus on EMDAS. And what I made here is I made a graphic organizer that helps you remember the rules when you are doing operations on like basis, when you're doing the operations of exponents, operations of multiply, divide, operations of adding and subtracting. It tells you what to do the exponents. For example, that one that we were just talking about, when we did 5 to the 5th divided by 5 to the 2nd. We have the same base. What is that base?
5.
5. And what are we doing to those bases? We are dividing. So what do you do to the exponents when you are dividing like bases? Arrow tells you to go subtract. You always do the thing underneath it. So this is in order of operations. You do the thing underneath it to the exponents. So I would do, for this, 5 to the 5 minus 2, sorry. And that would give me 5 to the 3rd. Okay? If I did something like 6 to the 8 multiplied by 6 to the 2nd. What are my bases? 6. Those are my like bases. And what am I doing to the bases? So we're going to look here. You will add the exponents. You will keep the same base, but you'll add the exponents. 6 to the 10th. And I don't know what that is, so I would type that in my calculator, some big long number, okay? Power would be if I had something like, I don't know, 7 to the 3rd, and then from that, we're going to take that to the 5th power. That would be power. So what do I do to the exponents? I multiply them. 7 to the 15, and that would be a really big number when I multiplied it out. I'm going to give you another power one that people were having trouble with in my other class. Let's say we had a power that was like 3. 3 to the 5th. What? It is, because what's the exponent on the 3?
1.
There's a 1 right here. Even though they don't write it, there is a 1. So I would multiply these exponents and get 3 to the 5th. And then I multiply that out in whatever, I don't know what that is. Nope, don't know what it is. But you can type that part in your calculator.
Yeah.
Okay? And we'll do a bunch of examples with all of that. Couple more things. Anytime the exponent is 0, the result is 1. If we have anything to the 0 power, it's always 1. And then this one, if the exponent is negative 1. If the exponent is negative. If you have a negative exponent, that means you have to reciprocate it. Here's some quick examples you could jot down. If I have 3 to the negative 1, I cannot leave the negative exponent in the problem. It means you have to reciprocate it. Currently, this 3 to the negative 1 is sitting over what number?
Uno.
Uh-huh. So if I reciprocate the 3, it goes down to the bottom. If I have something like x to the negative 1, that would be 1 over x. If I have 5 over y to the negative 1. Say it again.
Y over 5.
It's not going to just be flipped, because what is the exponent on the 5? Exponent on the 5 is 1, so that is a positive exponent. It doesn't move. But the y has a negative exponent, so only the y moves.
5 over 1 over y.
Or just move the y up. What you said first is fine, but you have to keep simplifying it. Jared said, what did he say? He said 5 over 1 over y. But you can't leave a fraction inside of a fraction, so that would be more complicated than just move it up. All right, but what if the exponent is not -1, but the exponent is -3? If you have like 5 to the -3, the negative part says reciprocate, including the 3 going down there too. The 3 part just says take that times itself 3 times. So this would be 1 over 125. Yeah. I get smaller. There's a really small one in your homework. Okay. This is all review what we're doing today. We've got 15 questions. We're going to go through 15 examples. You should have plenty of examples to kind of go back and look at when you do your 30-question homework, which a lot of people got done in my first class.
30 questions?
Huh? It's not on my computer. It's stapled. Whoever said that. Did you say it? What? That's tomorrow. Okay, so I'm going to go through these. They are on your worksheet. You can work ahead, but you should check your answers if you are working ahead. All right, first one. 5 squared is 25. X to the 3rd. Y to the 0 is 1. Z to the 4th. Done. Mm-hmm. Okay, next one. 28, x to the 3rd, y to the 0. Y to the 0 is 1. And I'm going to multiply anything times 1. I still get that same thing. Done. Question 3 is x squared times x to the 4th times x to the 3rd. So we're going to use our graphic organizer. We have all the same base. All the bases are x's. What operation is happening between all of these x's? And if we are multiplying with our graphic organizer, if we're multiplying, what do we do the exponent? We add them. So we're going to take x to the 2 plus 1 plus 4 plus 3. X to the 10. Okay, next question. Now, when you have numbers there, coefficients, and you have bases, you are going to treat them differently. The 2 and the 3, the coefficients, you just multiply them. Yeah, you just do what you normally do. But the m's, those are the bases that have exponents on them. What is the exponent on this second m? 1, right? So I'm going to have m to the 2 plus 1. So we get 6m to the 3rd. Do I take 6 times 6 times 6? No, because the 3rd is not on the 6. It's only on the m. Okay, so what we would normally do to the numbers. What we would normally do to the numbers. -5 times -2 times 3 times -2. Multiply all that together. -60. It's the variables with the exponents that have these tricks. We've got a squared and a to the 4th. Those are like bases. What do we do to their exponents? We also have y and y. So we go y to the 1 plus 1. Right, next one. So what am I using here when we have a parenthesis with an exponent outside? That is from our what is this thing? From our graphic organizer. That's power. So we multiply the exponents. What about the 3?
That's not an parenthesis.
Okay, so it just comes down. So we get x to the 2 times 2. If you can do 2 times 2 in your head, is it okay to go straight to 3x to the 4th? Yeah, it's okay.
I need to show you where. Do you know how you got
This
it?
is that. You should know how you got it, but this is Algebra 1 content. I hope that you are doing these in your head. I am showing all the steps, so you could go back and look at it later. I would encourage you to show the steps in your work, because these are notes. In your homework, though? I don't have to. All right, so this one here, there's an exponent that is on that 3 that is not showing.
Uno.
Right, so I'm going to put it there so that this makes more sense to me. When we have the entire parenthesis squared, that means both the 3 and the x squared get that power of 2. So we get 3 squared and x to the 4th. We get the squared to go to both of them. So 9x to the 4th. And we did this last chapter. We did this last chapter. We did this last chapter. Okay. This is just a review. All right. 4x, the entire parenthesis to the 0 becomes, so that's 1. 3x squared. 3 and x are missing their exponents. 1 and 1. So I'm going to take this exponent and multiply it. So we should get 9x squared. Okay. There are 2 different methods that I've seen people do for these. I'm going to go off of the chart, and then I can show you the other method also, but I'm going to go off the chart. So the chart says if we are dividing, we're going to subtract the exponent. You always want to subtract the top exponent first minus the bottom exponent. And then when you subtract them, they are automatically on the top. It is always on the top after you subtract it. Okay? So I get 10 to the negative 1. We don't like negative. Like, they're just so negative. Let's make them positive. Okay?
Yeah.
How do we make this positive? We reciprocate it. When we have a negative exponent, to get rid of it, we reciprocate it. So this will be 1 over 10 as our final answer. There is another method. Like if you think about 10 times 10 and 10 times 10 times 10, and you could like cancel out 2 of them. And what do you have left on top?
See, but if those are bigger exponents, then you got to write out a lot more tens.
What? Say that again.
If,
You like
it's a
the red.
bigger-
You like
bigger
this one better.
exponent. No, I like the other one better.
You like that
If
one
they're
better?
Big exponents. Then it's like,
Oh yeah, because you don't want to write it all out. But you could also do it this way. Same thing. So they're bigger exponents, you can do it that way. I just want to show you, like, every single method gives you the same answer. But if you're using the chart, you are subtracting, that's what your work would look like. I think some people tend to mush the two methods together and make mistakes. So when you're working on your homework, you just ask me questions. Make sure you're doing it right. All right, I don't know what number it is because I don't have the numbers on here. Number 11? Okay. When you have numbers, and then you also have bases with exponents, you have numbers and powers, treat them differently. Treat the numbers normal, like how would I do negative 9 over 12? Reduce that?
Yeah.
What's negative 9 over 12 reduced to? Okay, so reduce it. And then my A's, I've got A to the 7 minus 3. My B's, I've got B to the 4 minus 6. And they automatically go on top when you do the subtraction. Always go on top. So then when I simplify my subtraction, I get negative 3, a to the 4th, b to the negative 2, all over 4. But we don't like negatives. We want positive. Get rid of the negatives. How do we get rid of that negative 2 power? So what moves?
B.
Only the b power. So on the bottom I have 4b to the positive 2.
Okay. Problem solved.
Quick little note, yeah. Quick little thing. When you simplify, never leave a negative number in denominator. So this, it didn't happen for this one, but I know it happens in your homework. So I'm just putting it out there. And if you get to that point and you don't know how to get rid of the negative in the denominator, ask me, I will help you. Here, we have a negative in the numerator, it's fine. If the 4 was negative, it would not be okay. It would not be okay. All right, next one is 10x to the negative 3, y to the 5. Is there anything to do? We do not want a negative. So this is currently over 1. What's going to move?
The x to the third to the bottom.
Okay, only the x to the third, because 10 has an exponent of 1.
4.
So only the x to the third moves. Okay? Almost done. Negative 15 tenths. Treat it separately than the x's, because it's just a number, reduce it. Negative 15 over 10, reduce it. And then the x's, we are dividing, so if we divide, what do we do to your exponent? X to the 3 minus 4. So we get x to the negative 1. Just move it down, right. So we get negative 3 over 2x. That's all the negative exponent does, is it moves it up or down. That's all that negative part does. So 4x to the negative 6, y to the negative 4. The 4 doesn't go anywhere because it has an exponent of 1. X to the 6, y to the 4th, go to the bottom. Last one. Right.
1, 2 on the bottom.
So 2 divided by 4 is a half. And then this is confusing. So I'm just going to think about the rules.
You don't need the 1 though, because anything times 1 is itself.
Okay, so I didn't have to write it. I'm going to do x to the -3 and subtract -1. Why am I subtracting? Because of the division, that means I subtract the exponent. So I'm going to literally subtract that -1. And I'm going to get x to the -2, which I can't leave, so I bring it down the bottom. Jarrett, do I need the 1?
No, you do.
I need it, yeah. I didn't need it up here, but I do need it for my, oops. I do need it for my final answer. Because you can't just get rid of the numerator. Yep.
I just want to make sure you don't mess with something later. I swapped those.
You can do that. You can do that too.
Okay. Just making sure I'm not going to mess it up.
You got the exact same answer. You're doing it fine. Yeah. All right. Now your homework is the paper that is attached, exactly like the examples we were just doing, and there is a back to it.
Yeah.
And if you actually sit and work on it, you should probably get it done.
Yeah.
The other sheet is extra credit, and it is due Monday. If you'd like to do extra credit,
I don't.
no, I lied. It's not due Monday. I even wrote it over there. It's due Friday. It's due Friday. I know. I lied. So the extra credit is due Friday, and if you get done with the regular credit in class today, you can start on the extra credit. You should do the regular credit first because it's worth more. Okay? I'm coming around to help you answer questions, whatever you need.